On previous videos in this Git internal series, we covered the basic Git objects such as blobs, trees, and commits. We explained that a blob holds the contents of a file. We said that the tree is a directory listing containing blobs and or other subtrees. A commit is a snapshot of our working directory with some metadata such as the time or the commit message. Additionally, we discussed branches and how they're implemented, as they are nothing but a named reference to a commit. In this video, I'd like us to create an entire repository from scratch, all without using commands such as git init, git add, or git commit. Before that, let us clarify the process of how we record changes to a repository using Git. When we work with Git, we always have a working tree. What is a working tree? Well, a working tree is any directory on your file system which has a repository associated with it. Typically, it has a .git folder within it. A repository is a collection of commits. Each commit is a snapshot of what the project's working tree looked like at a certain point in time, whether on your machine or someone else's. A repository also has other things like branches, head, and so on. Now, unlike other similar tools you may have used in the past, Git does not commit changes directly from the working tree into the repo. Rather, changes are first registered into something called the index. I like to think of the index as my playground for the next commit. It's a way of confirming my changes one by one before I actually create a commit object. Some people call the index the staging area, and some people call it the index. These terms are synonymous, and I'm going to use them both. So let's create a repo. And first, I'd like to do it using the straightforward way, the perhaps normal way that most people usually use. So to create a repo, I'll use git init, let's say my repo. And this actually created a folder called my repo, and as I can see, a subdirectory called .git. So let's change dir into my repo, and let's use tree. And I can see that there are no subfolders here, but if I use tree/f.git, I can actually see that a lot was created within .git, and we'll get back to that later. So let's clear some space here, and let's see what we can do if we want to just create a file and commit it. So let's create a file with the content of hello, and let's name that file f.txt. So I've just created a file on my file system called f.txt, and its contents are hello. Now, where is it now? So it's in the working directory, but it's not tracked because Git doesn't know it yet. It has never been a part of any commit, and it's not part of the index. So if I use git status, Git will tell me just that. So there is one untracked file called f.txt. Okay. So if I want to commit that file, I first need to add it to the staging area or stage it. So to do that, I can use git add f.txt. And now git status would tell me this file is part of my staging area. This is a change to be committed. Now let's create a commit by using git commit -m initial commit. This is my commit message. And I'm going to use git status now. I can see that we're on branch master, nothing to commit, working tree clean. By the way, notice that we're on branch master, even though I've never mentioned this string specifically to Git. We'll talk about this later. And I'm going to use git log. I can see that Git has this SHA for a commit object that I've created with the message initial commit, and it's on branch master that head points to. Okay, so this was fun and simple. We're going to do it in a completely different way now. In order to really understand how a repo is built, we'll build it pretty much from scratch. We won't use git init, nor git add, or git commit. It will make us better understand what's going on when we usually use these commands. So let's go back to brief directory here, and let's create a new repo. But actually here I didn't use git init, so I just created the folder new repo, and let's get us some space and change dir to new repo, and this folder is currently empty. And git status is, well, not so impressed by this attempt. It says fatal, not a git repository, and it can tell us, well, you don't even have a .git folder, or at least it seems that it's telling us that. So let's just try to create a .git folder. Cool, so we've created a folder called .git with a new repo. So what about now? Nope, Git is still not impressed with us. So a .git folder is not enough to have a Git repository. So what is a Git repository? A Git repository is basically two things. It's a collection of objects and a system for naming those objects called refs, references. We may have other things such as hooks, but not always. A Git repo always has a collection of objects and a system for naming those objects. So let's create a dir for the objects first. So within .git, it's going to be called objects, and one for the system of naming those objects. So this one is within .git called refs, short for references. And we also need to have refs heads. Heads is the Git internal name for what people usually call branches. So far what we've done here is we created a folder .git with another subfolder called objects and another subfolder within .git called refs. And within that we have heads. So is Git status happy? Nope, not yet. So what does Git do at this stage? I mean, Git is trying to find its first commit or its first branch or something. So where does Git start when we use Git status? So as we know, Git needs to understand what the current active branch is. And for that, Git is looking for head. Now, what is head? So now we can find that head is actually nothing but a file. So let us create this file, and we're going to use echo for that. Yeah, what we're going to do here is basically creating a complete repo using echo and stuff like that. So let us echo ref and then refs heads master, which is the path of the master branch within the .git folder. And I'm going to echo that into the file .git head. So it's a file called head under the .git folder. And now let's use tree again. So what we have here is a .git folder, and within it a file called head with the contents of refs heads master. And now Git status seems happy. So Git status thinks that we are on branch master, even though we haven't really created a master branch, right? We don't even have anything within refs heads, but we told Git head that head points to refs heads master. So Git status thinks that we're on branch master with no commits yet. What about Git log? Well, Git log is not really happy because Git log knows we're on branch master, but it says we don't really have any commits yet. Okay, so just to note, Git is basically an API for version control. And it would be helpful at this point to make a distinction between two types of Git commands. There are plumbing commands and porcelain commands. The application of these terms oddly comes from toilets. Yeah, these things. Traditionally, toilets were made from porcelain and the infrastructure of plumbing, pipes, and drains. So we can say that the porcelain layer provides a user-friendly interface to the plumbing. Most people only deal with the porcelain. Yet sometimes when things go wrong, for example, and someone would want to understand why, they would have to roll up their sleeves and actually check the plumbing. These terms are not mine. They're used very widely in Git. I would probably have come up with other terms, but it's too late for that. So Git uses this terminology in analogy to separate the low-level commands that users don't usually need to use directly, that are called plumbing commands, from the more user-friendly high-level commands. These are called porcelain commands. So far we've dealt with porcelain commands. We used git init, git add, or git commit. But from now on, we're going to use plumbing commands only. So what I want to do now is to create a file and commit it. But basically what I want to do is not create a file in the file system at this point. What I want to do is create a blob and have its contents written to the object database. And I don't really have to create a file to do that. So what I can use the plumbing command. That would be our first plumbing command, git hash object. Now git hash object computes object IDs, but it can also create a blob from contents. So what I'm going to do now is I'm going to use echo again to echo the string brief channel is awesome. And I'm going to pipe that into the command git hash object. And I'm going to tell it to take its input from stdin. So it's going to read this input from here. I could tell it to read it from a file if I wanted to. And I'm going to tell it -w as in write. Please write the blob you're creating into the objects database of Git. And I have a SHA-1 here. This is the hash of the blob we've just created. So let's look at the folder now, tree/f.git. And I can see the .git now has head as before and object as before and refs as before. But within the folder objects, we also have a subfolder 12 and then the remaining characters of that SHA-1 hash. So why does Git do that? Why does it store the hash within objects as one folder containing the two first characters and then another folder with the remaining ones? So let's say we have another repo with 300,000 objects, and each one of these has a hash. It will take quite some time to look for that hash inside a directory with 300,000 objects. Unlike here, of course, where we only have a single object and it doesn't really matter. So Git divides that problem by 256. So by storing the first byte or the first two characters of the SHA-1 hash here as a directory, when I look up for that hash, he tells me first look into objects to the folder called 12, and there are 256 folders here max. So you look for the folder called 12, and then only within hashes that start with 12, only from these hashes can you look for the remaining characters. So this is basically an optimization for the lookup process. Now inside that object, what we have is a blob. How can we check that? So I can use the command git cat file -t, t stands for type, and provide this SHA-1 here. And Git tells me this is indeed a blob. Can I look at the contents of this blob? Well, yes, I can. I can use git cat file -p, another plumbing command, of course, and p stands for pretty print. So git cat file -p tells Git, go to your index, to your database, look at the object with this, with this ID, and then pretty print its content. And as I can see, Git can tell me brief channel is awesome, and Git is, of course, correct about that. Now, every time you use add, git add to stage something, we're not going to do that now because we're not using porcelain commands anymore, but every time you do that, then Git actually creates a blob of the entire file. That means it created not just for the changes. So if I were to change here, I know brief channel is awesome to brief channel is very awesome, then Git wouldn't create something only of the change of the addition of the word very, but rather it would create a blob with the contents of the entire file. So even if you change a single character, it means you'll have a different hash with a different blob, and the entire blob is stored within Git's database. So will there be any changes to Git status at this point? Well, apparently, no. Git status is not so impressed by what we have done. So we need to add it to the index. So currently we only have a blob and we want to stage it. So let's do that. So I'm going to use git update index to, update the index. And I'm going to tell it to update by adding something with the cache info of 10.06.44. This is not really critical for now. If you're interested, I'll provide more information in the comments. And here we can take the SHA-1 identifier of the blob we've just created. And I want it to become a file, so I'm going to give it a name. So let's give it the name brief.txt. Cool. So let's use tree/f.git, and we can see that we have everything seems the same, right? We have head, we have only one object, but something here is different. We have a file called index. So this fancy concept of an index basically is nothing but a file within the .git folder. Cool. So what happens if we use git status now? So there are two things we can see. One is that there is a file in green called brief.txt, and it's in green because Git understands we're staging a file called brief.txt. But it's also in red. So Git believes the file brief.txt has been deleted, and the fact that the file has been deleted is not staged. This happens because we added the blob with the contents brief channel is awesome to the objects database, and we told the index that the file brief.txt has the contents of that blob, but we never actually created that file. So how do we solve this? We can just take the contents of the blob and write them to our file system to a file called brief.txt. How can we achieve that using commands we've already covered here? Well, we can use git cat file -p. for that file, right? So I can use just that. Let's take the SHA-1 from here. So this would give me the content of the file, and I could write that content into brief.txt. And let's use git status. Cool. So now our changes are ready to be committed. They are staged, and Git is no longer thinking that the file has been deleted. So now it's time to create a commit object from our staging area. As explained in previous videos, a commit object has a reference to a tree. So first we need to create a tree. We can do it with the command git write tree. What this command does basically is record the contents of the index in a tree object. Cool, and it gave me out a SHA-1. So this probably means a new object has been created. So let's use tree and see that. Yeah, we can see a new object here starting with F0. Cool, so let's use git cat file -t to see the type of that newly created object. Any guesses what that would be? Yep, that's a tree. Can we look at its contents? Yeah, we can. Let's use git cat file -p for that. Cool, so we can see that we have a blob. Again, I'm not explaining this at this time. And we can see that we have the SHA-1 of the file brief.txt. So what about git status? Will something be different? Will anything be different? No, apparently for git status, nothing has changed because we haven't created a commit yet. So now we're going to create a commit object. And I hope you remember from that video where we covered git objects that a git commit has the pointer to a tree object. So what we're going to do here is say git commit tree, which means create a commit object pointing to this tree. What tree? This tree right here, the object we just created. Sorry, this one. This is the SHA of brief.txt's blob. This is the SHA-1 of the tree object. And let's add a commit message saying initial commit. And I'm going to clarify that this commit doesn't have a parent because, well, it's the first commit. Otherwise, we would have to add -p and its parent commit. How cool is that? So we actually created a commit object now. Let's do tree/f.git to look at the object folder here. Yeah, we have a new folder with the two first characters here used for the subfolder's name, 7D, and then the rest. So let's see, what is the type of this object? I bet you know the command by now. It's git cat file -t. And we can see it's a commit. And can we look at its contents? Let's use git cat file -p. Yep, as we can see, it's a commit file with the tree, with the SHA-1 we gave before. I'm the author and the committer, and with the message initial commit. Very cool. Now notice that these hashes, the hash of the commit, is something we're used to see. We look at commit hashes all the time when we use git log, for example. But the commit owns a tree object, and this tree object has its own SHA-1, as we learned in previous videos. Cool, so will anything change in git status for now? Well, no, and this may be surprising for you. Why hasn't anything changed if we actually created a commit object? Well, because it doesn't know what commit to look for. How does Git look for a specific commit? So we already know that it goes to head, right? So by going to head, it means it looks at the contents of .git/head. And the contents here say, okay, go to master branch. But what is master branch? So let's look at tree/f.git. We have refs heads, but we have never created the branch master. And what is the branch master? So basically, like many other things, it's just a file. It's a file that contains the SHA of the commit object it's currently pointing to. So let's take this SHA. Again, this is the SHA-1 of the commit we've created, right? So this is the commit, this is the SHA. And we're going to do now echo of this. So we're going to write this into the file within .git refs heads master. So what we did now is to create a file by the name of master within the folder git refs heads with the contents of this SHA. I could have done it using a git plumbing command. That would be probably better for some cases. So I could do it using git update ref and then refs heads master and then provide that SHA. So this is just the equivalent, but So let's copy paste this. So this is just the equivalent, but I would rather not do it now because I want to show you how I do it with Echo. There are some advantages to using the git update ref, but that's for another video. So after doing that, let's look at git status. Cool, so git status tells me that there is nothing to commit, working tree clean, and we've actually been able to create this commit object and link to it via the branch. So as we can see here, a branch is just a file inside .git/ref/heads, and it contains the hash of the commit it refers to. As we've said many times, a branch is just a named reference to a commit. And if we use git log now, we can also see that Git knows that head points to master and master points to this commit object we've just created. That's very, very cool. Okay, I think now would be a good time for a short recap. So let's test yourself and clarify that it's actually clear for you what we've covered in this video so far. So what two directories do we have to have inside .git? Well, we have to have objects, which contains the objects, and we have to have refs, which holds the references or names for these objects. How does a directory inside .git/object look? Well, it first has the first byte of the SHA-1, and then within it, there is a subfolder with the remaining characters. And why is that so? For a faster lookup, so when I try to look a specific SHA-1, a specific hash within the object folder, I can first go to the first byte, look for that only, and then look for the remaining bytes. Okay, when did we say a blob is created in a usual flow? Well, a blob is created when we add something. In other words, when it's added to the staging area or the index. And if I use git add to something, where are things stored at this point? In the index, and more specifically, we now know that it's a file called index that is found right here in the .git folder. Cool, so far we've been able to create a commit object from scratch, but now let's work with branches. So just as we've created a repository and a commit without using git init, git add, or git commit, now we'll create and switch between branches without using porcelain commands such as git branch or git checkout. I can understand completely if you're excited. It is indeed very exciting. So far we only have one branch named master. To create another one with the name of test, which is the equivalent of using git branch test, what can we do? So as we know, a branch is just a file within git refs heads. So I can just create exactly as I did here, echoing the commit cha of this commit. I could use the same command, but write it instead of writing it to .git refs heads master, I'd write it to .git refs heads test. And by using git log, I can see now that Git thinks that I have master pointing to this commit, and I also have test pointing to this same commit. Now, how do I switch to this newly created branch? So what I want to do is something like git checkout test, but I want to accomplish that without actually using git checkout. So to do that, I'm just going to need to change head. So I'm going to echo ref, and this time ref's heads test rather than master to .git/head. Now let's use git status. So git tells me I'm on branch test, and also if I use git log, I can see that head now points to test. All right, so let's commit something. So let's commit a new file. We already know how to do that, right? We can echo its contents, echo testing. So let's do it into git hash object stdin and -w to write it into the index. And now let's update the index. So I'm going to copy this SHA-1. I'm going to use git update index add with the cache info. Test.txt. And now I can write this tree. And I can also even commit it. So let's git commit tree with this hash. Testing something. But this time it already has a parent. So I need to include -p and its parent hash. So this is the parent commit. Cool, so I was able to actually create this new commit object pointing to its parent commit. And as we can see, git cat file -t. This is indeed a commit object. How do I look at its contents? I could use git cat file -p. So if I do that, I can see that this is the tree it links to, and it has this parent commit. Cool. But will git log know it? Well, apparently no. Where is our commit? So as you might have realized, head points to test, but we haven't actually changed test. So whenever we use git commit, Git takes care of this for us. It doesn't only create the commit object, but it also moves the pointer, the named reference, the branch, to point to the newly created commit. So in this case, we're going to do it ourselves. So we're going to echo, so the SHA-1 of our new commit object, we're going to echo that into .git refs heads test. And git log this time. Cool. So now git log sees that head points to test as before, but now test points to this commit cha, that is to this specific commit. And this commit points to its parent. So git log knows to go from head to test to this commit cha, and this commit object tells it to go to the previous commit as well. And this is basically how git log works. Very cool. So let's summarize. After setting the grounds in the previous videos, this time we actually dived into Git, stopped using porcelain commands, and switched to plumbing commands. So by using echo and other low-level commands such as git hash object or git cat file, we're able to create a blob, add it to the index, create a tree of the index, and create a commit object pointing to that tree. We're also able to create and switch between branches without using git branch or git checkout. I hope this has helped you better understand how Git works. And if you have any questions at all, please feel free to write them on the comments below. I'll also post additional videos regarding Git internals in the future, so be sure to subscribe to this channel so you get updates when this happens. See you soon.